Yes, we're getting ready for paper 2. And what I want you to remember is that paper 2, it's all about measurements. It's all about measurements. Then we look at maps and what? And scales. Then maps and scales, measurements, and a little bit of probability. Probability is also shared in paper 1. Anyway, what we mean by measurements, we expect to look at area, we expect to look at perimeter, we expect to look at surface area, we expect to look at volume. Yes, among all these, what I want you to remember is that 1, before you tackle or before you touch any question, units, the units have to be the same. Then number 2, learn how to substitute. Learn how to substitute into the given formula. Please do not just give up and you say, since the formula is given and I don't know how to do this, you just leave it. Please substitute. Where it says pi, put the pi. Where it says radius, put the radius. Where it says the height, put the height. Don't give up. All right. Step number 3. Please use your calculator properly. Don't give us answers that are half-baked. All right. Formulas. Try to remember some formulas if it's not given. Okay, let's look at area. If it's area of a square, what are you going to do? The formula for area of a square will be area will equal to side times side. For square, they will only give one side, then you get that. What about if it was the area of a rectangle? Area of a rectangle will always be L times B. Then a triangle, area of a triangle will always be half times the base, then times the height. This is a triangle. And we are looking at area. Then area of a circle, remember, this is a circle, so the formula will always be pi r squared. This is area of a circle, where pi is 3,142, and the r, it's radius. Radius times radius, or radius squared. Then, how do we get the radius if it's not given? That means they would have given you either the diameter, which will be, you divide the diameter by 2, and you get your radius. Radius is half the diameter, if it's given like that. Please remember the formulas. We shall look at the continuation there. Perimeter. When you look at perimeter, what is perimeter? Perimeter, one can say the total length around a given shape. If you don't want to say shape, you can say it's what? Surface. Altogether, as you have length around, then you get your 2 marks. Usually it's 2 marks. Then how do you get the perimeter of a square? Perimeter of a square. We shall just look at some questions very fast here soon. Perimeter of a square, we shall say perimeter of a square. Remember, square has 4 sides equal. So it will be 4 times the measurement of one side. Whereas perimeter of a rectangle. Perimeter of a rectangle will always be 2 into L plus B, whereby our L there, it's the length, the longer side of this of the rectangle, and the B is the breadth, which is the shorter side. If you don't want to use breadth, you can say width. But before you substitute into the formula, units have to be the same. And look at the question. What does it require you to do? Look at the question and what does it require you to do? A bit of, let me see, volume, surface area. Okay. For a triangle and a circle, perimeter, a circle, its perimeter is called the circumference. You understand? If you cover a distance in a round shape or around a round shape or circular shape, we call it the circumference. And this takes us back to what we call Wi-Fi, your Wi-Fi or Bluetooth. We believe they work in circles. That's why we say, what's the radius? How much does it cover? Okay. We look at the perimeter of a triangle. Since these are 3 sides, we shall say side 1 plus side 2 plus side 3. This is perimeter of a triangle. And circumference of a circle. Circumference of a circle, we use 2 methods. One is being 2 pi r, or you can say pi d. These 2 formulas. Now, it will depend. If you're given radius and you want to get the circumference, definitely you'll use this. If you're given diameter and you want to look for the circumference, you will use this other one here. Either way. Okay. Volume. When we look at volume, this is the space occupied or taken up by a given object. Remember that, né? Volume, space taken up. Then the sister to volume is called what? Capacity. Capacity, it's the normal volume in normal life. What do I mean by that? Volume here, this we use it for calculations. You understand? I'll give an example of a 2-liter bottle. A 2-liter bottle, for us to get the 2-liter bottle, first we have to measure its height and we need to know its circumference. But in real life, that capacity is going to be in what? Liters. Altogether. Then what is capacity? Capacity is the amount a given object can hold. You understand? Or it can contain. How much can it carry? That's capacity. How much space does it take if I put it in the fridge? That is volume. Not together. So this volume goes hand in hand with the surface area. And this will be, we shall be looking at 3D objects. We shall be looking at 3D objects. Formulas, please try to remind yourself of the formulas. When do you use what and how do you use it? My trick or your trick could be, if you know the formula, please, or if the formula is given to you, please write it down. After that, substitute with right values. You get a mark for that. You get a mark for that. Okay, let's look at the objects that we are looking at. If you look at surface area and the volume, usually the surface area or the objects we usually look at as an object that will look like this, and it's called out a cylinder. If you're to look for the volume of a cylinder, please just know that you always take pi r squared what? Height. And if you're to look for its surface area is the amount of material an object is made of, or the total area of all surfaces. Now, for this one here, it has 3 surfaces. It has the one on top, it has this one here, and it has one at the bottom. So how much material do you need? Then you shall be looking at surface area. So if it's surface area, we shall say for a cylinder, it will always be 2 pi r into r plus h. These are the 2 formulas we expect you to remember. If the formulas or if the question is a little bit complicated, the formulas will always be provided. Then we have looked at the cylinder. The other 3D object is what we call the rectangular prism. Rectangular prism having a height. This is the breadth and this is the length. I hope you see this nicely. Okay. If it's this volume, what shall we say? We shall say L times B times height. Whereas if it's surface area, we shall say 2 outside LB plus BH plus LH. Together? Here they are multiplication signs, where L is the length, the B is the breadth or width, then the H it's the height. Please remember this. This is what manages, or this is what covers measurements. Also reading from given values, manipulating formulas. All right. Another thing that we should expect, and okay, measurements. This is done. Measurements. This is done. We look at area, perimeter, volume. What about maps and scales? One, know the type of map that you're dealing with. Then look at what type of scale is it. Can you use it or can you tell? Because when you look at maps, usually when you look at maps, we are looking at maps. We shall look at maps. We usually look at its type, the type of map, whereby we have provincial. This shows provinces. National map, it shows the national roads, the N routes, and the N roads, ne? National routes. Then type of map, yes, we talked about the national map, provincial. We can have the estate, which is the residential one. We have street map. Street map is the one that shows the streets of a given town. Then we have what we call a strip map. A strip map is that short one, showing distance from 0 to a given. It has it's like a line. Actually, it's a bar together, but it's showing zero distance from the start to the end. Then the strip map, another name for the strip map is called a route map. Okay. Now, the maps, okay, that is it. Scales. You should know what scale you're going to deal with. We have what we call a bus scale, which could be another name for a bus scale, or let me say bus scale. We have what we call the line scale. These form what we call, they are called the linear scales. Together, that's a general name for those bar. If it's not a bus scale or a line scale, we have what we call a number scale. A number scale, another name for a number scale, some people call it a ratio scale. These are in form of diagrams, whereas a number scale or ratio scale, it's in a form of 1 is to a given number. Let me take 500. Now, if they ask for the meaning of the scale, please always know any number on the left, this is on paper. That's what I want you to remember. And the number on the right, this is in real life. What do I mean by that? If they ask for the meaning of this scale, for example, how are you going to say, or how are you going to give it? This scale will be 1 unit on paper is equivalent to 500,000 units in real life. That's what it means. Together, if they ask for the meaning of the scale, that's what you will say. That's what you will say. We shall also look at a certain part of measurement, that is packaging, very soon. Okay, the meaning of the scale, what did we say? The meaning of the scale, we say 1 unit on paper represents, some people say represents, others say equals, represents 500,000 units in real life. That's the meaning of this scale of ours. Together, By the way, also a bar scale turns into a it turns into a number scale. We shall see what happens. Anyway, this was a revision a little bit, knowing what you'll expect in paper 2. Measurements, maps and scales, probability. Okay, under maps, what else do you expect to see? We shall know how to deal with distance. How do we use the scale distance when we look at scales? Distance, for example, you will measure. Oh, if they tell you town A, so the distance between town A and town B is, let's say, 54 millimeters. The moment you see millimeters, just know it's on the map. So, what is this distance in real life? What's the distance in real life? Let's use our scale that we have here already. If 1 unit is equivalent to 5,000, so what will it be? So what you're going to say, 54 times 500, 54 times 500,000. So this answer here becomes 54 times 500,000. The answer became 27 million. But take note, these are millimeters. So in real life, it's either in meters or kilometers. So let's change this to kilometers. So millimeters to kilometers, you divide by a million. Divide by a million. So these zeros will go with that. And our final answer becomes 27 what? Kilometers. That is what we shall be expecting. Another thing after these maps, I believe you know very well, distance, time, and speed. This is what we expect to see on Monday. So what shall we say? They usually use this formula here, this triangle here. So should you happen to forget anything, you have to remember this. So if they ask for time, we shall say it's the same as distance over speed. If they ask for speed, it's distance over time. And if they ask for distance, it will be speed times what? By the way, they cannot ask for two missing values. Ne? They ask for one. That means the other two will be given. All right, let's look at a little bit of packaging. Packaging. This is an arrangement made. Let's look at packaging. Packaging of rectangular boxes into rectangular box. Definitely this will be making sense here. Now we have two methods. Okay, there are two items that we usually pack in mathematical literacy. We have either cans in form of cylinders, or we have boxes in form of rectangular boxes. Definitely the cans can be packed into cans, or other boxes can be packed in boxes. Cans can be packed in boxes. Anyway, if there are two methods arrangements that we usually use. One, it's called the lengthwise. Lengthwise, if it happens like in this form here, that means the length of the smaller box will sit on the length of the bigger box. And if we need to find out how many boxes will fit on the long side, how many boxes will fit on the short side. Anyway, lengthwise, this simply means it will be length of the bigger box, allow me use this, divided by the length of the smaller box. Always, it will be like this. What are we doing? Another thing that you have to take note of when we look at packaging, we don't round up, but we round down. We don't round up, but we round down. We're going to use this box here. Let's take some clean measurements here. Let's hope. So if this box had a length of 200 millimeters, a width of 150 millimeters and a height of 40 millimeters. And this box here, if the box had, let's say, the box has a, let me see, a box has a, let me see, this is what? A box has a length of 25 meters, a width of, let's say a width of what? Let's say we have a width of 45 centimeters and a height of 120 millimeters. What you have to take note of before you do the calculations, what you take note of before you do the calculations, we are going to say how many boxes will fit on the short side, how many boxes will fit on the short side, and how many boxes will fit on the long side. Now, this is done in a way, for example, if you've seen how people pack things, let's say in a room, if a room looks like that, this is the floor of the room. So meaning we need 3 boxes here, and we need other, you see that? So this is how many boxes we have. We have 1, 2, 3. Then 1, 2, 3. So these will be 3 boxes on the short side, still 3 boxes on the long side. So all in all, how many boxes shall they be? We shall say 3 times, and we end up having what? 9. So this room can take 9 boxes. Okay, let's come back to our example that we have here. We are going to pack small boxes into the big box. But as I said, we shall need to convert the units first. All right? So you're going to allow me to do this very fast. We are saying the bigger box. Let me write big here. It has a length of 0.25. These are meters. It has a breadth of 45. These are centimeters. And it has a height of it has 125, millimeters. These are meters, these are centimeters, these are millimeters. Then let's come to the smaller box. The smaller box, the length of the smaller box, they're telling us is 200. These are millimeters. Then it has a breadth of 150 still. These are what? The smaller box, and it has a height of 40 millimeters. Now, we said before we do anything, both units have to be the same. Both units have to be the same. Let's change them to centimeters. Let's change all the units to centimeters to make sense. What we are going to do, you usually balance, or we usually change it to the smaller, or according to the scenario. Okay, so if you're to change meters, I'm changing this to centimeters. Meters to centimeters, we need to multiply by 100. And this becomes 250. These have become centimeters. These are already centimeters. We don't need to change them. These ones, millimeters, we divide by 10. So it has become centimeters. These are all millimeters. We need them to become centimeters. That means you're going to divide by 10 throughout. So this divide by 10, you have 20 centimeters. Then this divide by 10, we have 15 centimeters. 40 divided by 10, we have 4 centimeters. So everything is in centimeters. We are good to go. So lengthwise, how many boxes will fit on the short or the long side, on this side here? If you are to pack them coming this side like this, how many boxes shall we fit? So this will become length of the smaller box, length of the smaller box, length of the smaller box, sorry, a length of the bigger box, length of the bigger box divided by the length of the smaller box, which will become what? What's the length of the bigger box? It's 250. Divided by the length of the smaller box, which is 20. So how many boxes shall we fit? So we shall take 250 divided by 20. You have 12,5. Remember, we said we round down. So since we are rounding down, this becomes 12 boxes. 12 smaller boxes will fit on the long side. So as we pack them, here we shall need 12 of them. Now, ask yourself, what about on the short side? The short side, we shall say width of the bigger box divided by the width of the smaller box. And here we know. What's the width of this bigger box? It's 45. Divided by the width of the smaller box, 15. So here's the straightforward answer, which is what? 30. Remember, these are boxes. These are boxes. So what about the layers? But before we reach the layers, only on the lower floor or the first floor, how many boxes shall we have? This means we shall have 12 times 3, which becomes 36 small boxes. So we have 36 smaller boxes. So how many layers will fit inside here? So for layers, it will be the height of the bigger box divided by the height of the smaller box, which is 125 divided by, sorry, not 125. It's 1,25 divided by 4. 12,25 divided by 4. We have 3,122. So this answer here, 3, so in other words, these are 3 layers. So all in all, how many boxes shall we? So we shall have the 36 times 3. 36 times 3. So one big box will take 108 smaller boxes. Let me hope you have understood what we are dealing with. Okay. Then let's look at another method, which is called the widthwise. Widthwise simply meaning the width, the width of the smaller box, sorry, the width of the bigger box versus the width of the smaller box. And still the same way. Okay, widthwise, we are finding how many feet on the short side, and lengthwise, how many feet on the longer side. When widthwise, how many feet on the shorter side? When width versus width, width of the smaller box versus the width of the bigger box. Then lengthwise, how many feet on the longer side? How many feet on the longer side when the length of the bigger box versus the length of the smaller box. Then height-wise, it's the layers. How many layers shall we have? Unfortunately or fortunately, I've just done this. Okay? So width-wise, how many feet on smaller, the smaller side, or the breadth of the box? You understand? Then lengthwise, we are looking for how many feet on the longer side. That's what you're looking at. Together? Then if we to look at layers, how many layers shall we have? How many will be packed on top of each other? That means we shall take the height of the bigger box divided by the height of the smaller box. But we have some scenarios whereby we have some scenarios. Look at that one there. Now, this one has changed a little bit. Lengthwise. The width of the smaller box is packed along the length. So now this has changed a little bit. And what will be the method? So since the length, the width of the smaller box is facing the width of the length of the bigger box, to know how many will fit on the long side lengthwise, it will be length of the bigger box divided by the width of the smaller box. Let's take our measurements again. We said this was 215. We said the smaller box here, the smaller box had, the length was 200 millimeters. Its width was 150 millimeters, and its height was 40 millimeters. The bigger box, for it had a height of 125. These are millimeters. Then the width of 45 but centimeters, and the length of 0.25 meters. As we had agreed, and which is true, before we touch any calculation, all measurements have to be the same. So we agreed that the measurements are going to be centimeters. So this one here, millimeters, change it to centimeters. We only divide by 10, becomes 12.5. These are centimeters. The length, we multiply by 100. We want them to become centimeters. And we go to the answer as 250. Sorry, we get it as 25, not 250. We get it as 25. So here now we are looking at this. So what's the length of the box? The length of the box is 25. What's facing it? It's the width of the smaller box. Remember, all this you also have to change to. This is 15. This is 20 centimeters. And this is 4 centimeters. Please, whatever is not given in the paper and you show it, you get a mark. Anyway, so now our width of the smaller box, we're saying it's 15. So 25 divided by 15. 25 divided by 15, we have an answer as 1,667. In other words, it's what? One box. Then that means if the width of the smaller box is facing the length of that means the length is facing the width. So we shall say width of the bigger box divided now by the length of the smaller box, which is the length of the big box, width of the big box is 45, divided by the length of the, which is 20. So 45 divided by 20, you have 2.2. So this is approximately 2 boxes. So on the first floor only we have 1 times 2. So we have two smaller boxes. 2 small boxes. Anyway, what about the layers? Layers will be the 12.5 divided by the 4. We see that it will be 3.142. So the answer here became 3. three boxes. So all in all, what will it be? It's the 1 times the 2 times the 3. So here it takes 6 small boxes. We continue and we look at that. This one, the same story. Okay, what about if you're to pack cans? If you're to pack cans, you understand? Cans are packed into a larger box. So this means how many shall we have on the smaller side, and how many shall we have on the longer side, which is length, and how many shall we have on the shorter side, which is, you understand? If it's only one layer. So now what we're going to do, cans is a little bit different, but it's fine. It will be, let's say, it's 0.2 meters. Then here we have here we have 0.8 meters. Let's say the height is 6 meters. Then the can is let's say 6 centimeters, and it has a diameter. It has a diameter of 5 centimeters. So in this case, we are finding how many will fit on the long side. We need to know how many cans. If I pack cans here, like how many will fit. So on the lengthwise, we shall say length of the box divided by the diameter of only one can, which is length of the box. Mind you, the units have to be the same before you do anything. Ne? So let's change the meters to centimeters. This one times 100, which becomes 25 centimeters. 25 centimeters. Then this times 100, it becomes 80. And the height times 100, the height, sorry. The height has to be 0.6 also. The height has to be 0.6 to 100. Okay, so now everything is good to go. Length of the box, we are saying it's 25 divided by the diameter of the can. The diameter of the can is 5. So we shall say, okay. So on the long side, we shall need 5 cans. What about on the short side? It will be the width divided by the diameter of the can. So the width is 80 divided by 5. What do you end up having? 16. 16 cans. So all in all, how many cans shall we meet here? So it's 16 times 5. The answer becomes 16 times 5. The answer becomes 80. So this small box can carry 80 cans in one layer. Then, what about the layers? So it becomes height of the box divided by the height of the can, which is 0.6, which is 6. 60 divided by the diameter of the can, it's 5. So they are 12. So 12 layers. So in other words, we have 12 layers. Each layer has 80 cans. How much do you get? How much do you get? So it can carry 960 cans. 160 and 60 cans. So that is our answer there when it comes to cans. Cans have no either way. Yeah? All you have to know, how many fit on the long side, how many fit on the short side. Then everything will be fine. Okay, let's look at another example here. Okay, let's look at this example here. This is what they were telling us. Determine how many cans can be packed in a box. Show all your calculations. Number one, check if the units are the same. Check the measurements of the can. This is radius. Take note of that. For us, we need the diameter because when you're to pack the can inside here, inside this box, you won't pack half a can. That's why we don't need the radius. The radius will help us get the diameter. Okay, how many cans will fit? So ask yourself on the long side. On the long side, how many will fit? On the long side, how many will fit? On the long side, how many will fit? So what are we going to do? We shall take the length of the box divided by the diameter of the can. Now, what you have to know, the length is in centimeters, well and good. The width is in centimeters, but the height is in millimeters. Let's change it to centimeters. We get 18 centimeters. Okay, the radius and the height, they're all in centimeters. Good, but we need the diameter. So the diameter is going to be 2 times radius, which is 3 times 2, and the answer becomes what? 7. Good. So now we are good to go. The length of the box, 85, divided by 7. What answer do you get? What is the answer that you get there? Divide for me, 85 divided by 7. I believe you have 12,14. So we say we need 12 cans. Then what about on the short side? On the short side, we shall say the width of the box divided by the diameter of the can, which becomes 43 divided by the diameter. 43 divided by the diameter, you have 6,14. These are cans, but then the real number is going to be 6. 6. Anyway, then what do we say? In the whole box, how many layers do we need? So this will be the height of the box divided by the height of the can, which will become, height of the box is 18, divided by the height of the box, which is this much. Take note of that. 18 divided by 8,57. So this gives me 2,1. So in other words, we are taking what? So all in all, how many cans shall we have? So on the long side, we have 12. On the short side, we have 6. How many layers? 2. So this becomes 144. 12 times 6 times 2, 144. So this means the number of cans that we shall need, 144 cans. This is packaging. Let's look at this example, another one here. Look at that. Calculate the number of small boxes that can be packed in the larger container / box if the length L of the small box is packed along the width. So the moment you hear this, take note of that. The length of the smaller box is packed along the width of the, so this is where we go, meaning the width of this bigger box divided by the length of the smaller box. Why? Length of the smaller box packed along the width of the, so the width is, so what shall we say? Make sure that all the units are the same. Yeah, this one has to change. Width has to change here, divided by 10. It's 8,7 becomes centimeters. We are good to go. What's the width of the bigger box is 42,1. Divide by the length of the smaller box. What's the length of the smaller? 10,2. What answer do we get? 42,1 divided by 10,2. We have the answer as 4,127. Round down, these are 4 boxes on the short side. What about on the long side? Remember, we are looking for maximum. How many? Calculate the number of boxes that can be packed, you understand? So what about, that means the length of the bigger box versus the width of the smaller box. So length of the smaller box, it's, length of the bigger box, it's this much. Whereas the width of the smaller box, it's 8,7. Remember, units have to be the same. So 54,8 divided by 8,7. Here we have the answer as 6,2988. So we take the number down, which is what? 6. Then ask yourself how many will fit in the layers when you pack them on top of each other. So it's height of the bigger box divided by the height of the smaller box, which is 33,65 divided by 6,5. 33,5 divided by 6,5. So we have the answer as 5,153. So which becomes 5. So all in all, what's the total? It is going to be the 4 times 6 times 5. 24 times 5, 120. Small what? If we have packed them in this arrangement that they have told us, whereby the length of a smaller box is versus the width of the bigger box. So this is the maximum number of what? Containers that we have there. Okay, let's look at another scenario here that we have. A box of 24 cans of Diet Coke is displayed. Look at that. In this case, what do they want us to get? They have given us the radius of the Diet can as 3,5 centimeters. The cans are packed in the picture. Calculate the minimum length and the minimum width of the box. Now, definitely, width, it's this smaller part that we see here. You know, from here to here, what is it? This is the width. Then, from here to there, it's the length. Minimum. The minimum we can have, it's going to be width. How many cans do we see on the width side? We have 1, 2, 3, and 4. So if there are 4, so that means my width is going to be 4, but width times the diameter of each can. They gave us the radius as 3,7. So what is the diameter? Diameter equals to 2 times what? R, which is 2 times 3,5. Then the D becomes what? 7. So we come here, the width is going to be 4 times 7. The answer is what? 28. What about the length? The length is going to be, how many cans do we see on the length? There are 6. We have 1, 2, 3, 4, 5, 6. It should be 6 times the diameter also, which is 6 times what? 7. And the answer became, remember we are looking for the maximum measurements. That is it. That is it. The height, we can't need the height because already the can is halfway there. So we don't need that. We have another question here. These are refrigerators. The dimension of a standard fridge, the dimensions of a standard fridge are 1,688 millimeters by 600 millimeters by 542 millimeters. The fridges are kept in a warehouse for delivery. The dimensions of the warehouse floor are 15 meters, 12 meters. Calculate the maximum number of fridges that can be stored in the warehouse. Remember, the fridges cannot be stuck and should remain upright at all times. So what are we going to do? Here in this scenario, as we said, the units have to be the same. Allow me to do that. 1,000, because I want them to become meters. I'll divide by 1,000. So now the dimensions are going to become 1,688 by 0,6 by 0,542. So how many will fit on the long side, lengthwise? So we shall take the length of the room, divide by the length of the fridge, which is going to be, length of the room is 15, divided by 1,6